Hey, it's the Reckless Retiree here, and I'm going to do a bit of an experiment. I found this information online. This article, it says rapid hydrogen generation from aluminum water system by adjusting water ratio to various aluminum hydroxide levels. And it says that the proper aluminum hydroxide water weight ratio is 3 to 15 to 50. So I have a scale here, and it is reading in it's kind of hard to see what that is. I think it's grams. I think that's a G. Yeah, it's a G for grams. So, I have an aluminum can here, the bottom half of which I'm going to use as my container. And it weighs 5.4 grams. Of course, I'm going to tare it. Okay, so now I want to add 3 grams of aluminum. So I'm going to trim off little bits of this aluminum and put them in there till I have 3 grams. I'm thinking it's not going to take a whole lot. And then, in the same way, I'm going to take 15 grams of this aluminum hydroxide that I've ordered. It's actually meant to give to pets. I don't know how pure it is. It didn't say in the, that would probably be important to know. I'm going to assume it's 100% aluminum hydroxide. So I'm going to get 15 grams of that. And as I get the different things, I'm going to, parts of it, I'm going to put them in this glass right here. So first, 3 grams of aluminum, then 15 grams of aluminum hydroxide, and then 50 grams of water, and we'll see what kind of reaction we get. This is supposed to get a really great hydrogen making reaction. So I changed it to ounces, and this is 0.029 ounces, so I'm going to call that close enough to 0.03 ounces, and then I'm going to 0.15 ounces of aluminum hydroxide. I just thought of one is I'm going to put the aluminum hydroxide in this little aluminum container, which doesn't make a lot of sense, but maybe it won't react without the water. Secondly, I decided to go with foil instead of the aluminum from the can because that has plastic for the label on it, and that wouldn't be accurate. So I went with foil. It's also thinner, so higher surface areas would get more of a reaction. So I have 0.148. I'm going to call that close enough to 0.15 of the aluminum hydroxide. Different container, which I tared, and then this is 0.502 of water, which doesn't seem like a lot. So obviously the water is a lot denser than the aluminum hydroxide or the aluminum. We'll see what happens. Well, we're not going to be able to see bubbles of the aluminum, of the hydrogen, so I'm just going to pour more water in here. And this, by the way, is RO water. Yeah, there's quite a bit of bubbles going on here. Well, of course, the question is this hydrogen? And the only way I know how to determine that is by trying to light it. But I have to have a lot more of it than this than to light it, I think. Well, it just didn't work out in the glass, and my wife didn't want it in the house, and so I came out to the garage and I put more water in it, the same aluminum foil and the same aluminum hydroxide. So another way of determining if there's actual hydrogen being made is to see if we get any gas in the balloon. So that's how I'm going at this point. I'm going to set this outside the garage because it can't be in the garage either. And we'll see later if there's any gas in the balloon. So the opposite happened of what I was hoping for. I was hoping that I would fill this balloon with gas, hydrogen gas. But look how it's sucked in there. It's like it created a vacuum somehow. Very, very strange indeed. So I'm going to take the balloon off. I'm going to add a ton more of this aluminum hydroxide, which I don't have any other use for. So I might as well just put it in there and see what happens, right? Okay. So I'm going to take the balloon off. I'm going to put a bunch more in there. I'm going to put the balloon back on. And we'll see once again if we make any hydrogen. Okay, there's the funnel. Here's the stuff. Here's a spoon. Who would have believed this is aluminum? Yikes. Don't knock it over. I'm going to go whole hog and add 3 spoonfuls. All right. I know, I'm a messer. Okay, so I'm going to put the balloon back on. This is actually frozen. You can see the layer of ice, and you can see the aluminum hydroxide I just poured in there on the surface. So I'm going to try pouring in, if I can do this while filming, some hot water from my Keurig. So now I got a ton more water, same amount of aluminum, and I've added aluminum hydroxide, but it makes you think that you should add even more aluminum hydroxide since you have so much more water. Of course, I got the ratio way off now. It was supposed to be by weight, 3 parts aluminum to 15 parts aluminum hydroxide to 50 parts water. That's what the formula on the technical paper said. Looks like there's still a layer there. I think right there. Got a bunch of ice cold water on the bottom with ice, aluminum hydroxide, Of course, the aluminum's down there at the bottom. And then the hot water on top. I think I might add some more aluminum. Get the ratio really off, right? I could try dropping something down through there and try to stir that mess. See if I can break through the ice. That might be fun, right? What people consider fun, I'm telling you. Okay, gotta find something to fit through the next one. So, here's a nice piece of copper pipe. Add some copper to the mix, what do you think? And now it broke through the ice. And I will stir it up with it. Okay. That's cool. It's really cool that that just happened to fit. So remember, I don't know, what is that, what do they call that, a 1/2 inch copper pipe, or is it considered 1/4 inch? Let's see what the label says. I never have gotten, whoa, where am I? The camera's way up here, Jason. Okay, if you can read barcode, here we go. It's called 1/2 inch. All right, let me flip it over so we can read it upside right. Okay, there we go. Whoa, dude. I think that's what that says. Anyway, it fits perfectly in the neck of a wine bottle, so just remember that. Again, after stirring, I don't see much reaction. Just see a little bit of aluminum. See the aluminum floating on the surface? It's kind of fun. You can see through the bottle, and it's blue, my favorite. I don't see any bubbling going on. Oh my goodness. Oh my goodness. So, what should I do? Well, empty the ante, right? That's of course what you should do. I'm going to add more aluminum and more aluminum hydroxide. Well, the bottle with the aluminum and warm water and aluminum hydroxide did not make any gas. So I am going to add some lye to it. And it'll be interesting to see what a combination of the lye and the aluminum hydroxide, should make. So here in a minute, I'm going to do that. Listen to that. Now I'm going to stand back and see what happens with this balloon. If it bursts, I'm a little afraid to take it off without gloves on because I'll get the lye on my hands. One possibility would be to tie a string around the base and then let the gas push it off. I've seen somebody else do that online. It's about as full as it can get, I think, before it bursts. We'll see what happens. Oh my gosh, there, look at it go. Let me stand over here by the fire. It's definitely going to burst. That was fun. Didn't burst, just popped off. You can see all the hydrogen coming out. And you can also see why it's not floating. Because there's a heck of a lot of water vapor in with the hydrogen.